All right, let's do a quick one. Let's go. So I'm going to give you a power series representation of e to the x, which is equal to the sum of k is equal to, or the sum of k is equal to 0 up to infinity of x sub k over k factorial. And just writing that thing in so we can have a quick discussion on, hey, I'd like you to go ahead and try and integrate this. This is just kind of the point. Why the hell are we doing this? This is silly. Why are we going crazy with it? And for some of you, if you're like an engineering major, yeah, none of this really. I mean, you actually might use some of this, but you'd relearn it. But what this will do is this allows us an opportunity to be able to represent things or find values. Something that's not integrable. So what I'd like to do first is just kind of write out a few of these terms. So we start at 0, you're going to get 1. And then you're going to get x over 1. And then you're going to get x squared over 2 factorial. And then you're going to get x cubed over 3 factorial. Plus dot, 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 and it goes on forever. Well, we learned that little trick where we can replace the variable, right? See that e to the x? That e to the x? Or the e to the negative x squared. So if we want to do e to the negative x squared, this would be 1 plus negative x squared over 1 plus negative x squared squared over 2 factorial plus negative x squared cubed over 3 factorial plus dot, 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 and it goes on forever. So we look at this, and we're like, all right, so e to the negative x is equal to 1 minus x squared. The squared, we'll get rid of that negative, that'll become a positive, so you get x to the 4th over 2. 2 factorial is 2. The cube is going to keep the power, and we're going to get x to the 6th over 3 factorial, which is 6. And then the next one would be x to the 8th, 24, and it's going to go on and on and on and on. Well, now we could actually just integrate this thing and be like, well, now, what's the integral of this? What's the integral? We just go term by term, and we can find out that we have a great approximation by 5 divided by, that's going to be x to the 5th over 10, minus, that's going to be x to the 7th over 42, plus x to the 9th, I don't know, 9 times 24, what is that? 180 plus 36 more 216. It'll go on and on forever. Well, if you wanted to find something that was in that interval of convergence, like I'm not telling you the interval of convergence, well, gosh dang, we can find the integral. This is. If you take all of the terms, this is the integral of e to the negative x squared. If you take out every term, but if you wanted to approximate something, it wouldn't be all that bad. So this is somewhat of the game. This is why we need things. Not everything is integrable. These are the tricks. These are the ways around it. So when you say something's not integrable, it's like, well, I can still find the gosh darn integral. We just use power series instead. But the thing is, nobody wants to use power series, right? Are you enjoying this section? Are you having fun through chapter 11? I know I didn't. It's rough. But it's powerful, and it can do things that other, sorry about the puns, that just direct integration won't do or can't do. And the thing is, in real life, we don't need things to be exact. We need them to be somewhat close with decimal places. And you've seen our approximations. They've been super close with just a few terms. They work out great. So this is our game. I don't know if that made any sense. I just wanted to throw it in so maybe you get like, why? Why are we doing this? But again, I'm pretty terrible at teaching this stuff. I hope you're understanding some of it. But even with a wonderful teacher like I had, Professor Lucero, I still only understood about maybe 2% of this. So hopefully you're doing well. We're going to move into 11.3 next. Maybe I'm kind of considering, I don't know. We'll see what we do next. All right. See you.